Hello, future developers, and welcome to my tutorial on data visualization. As you already know, in this current world, we have a lot of data from text, visuals, images, audio, a whole lot of them. And then these kind of data, when being processed, it could actually give us like trends or insights as to how to make good use of data and also make some predictions. So data visualization would actually help people to be able to make business solutions or give out business solutions or outcomes, and to also um, tech trends. Okay, that would help them make informed decision as to what to do and then what not to do. So welcome to my course on data visualization. Okay, so what is data visualization? It's simply it's just a pictorial representation of information or data. Okay, as you can see in this GIF file here, okay, just pictorial. So it could be a data collected on a fish farm. Okay, maybe you want to determine the or see the oxygen level, carbon dioxide level in the water, impurities and all that. Okay, and also trends, maybe YouTube or video trends, art, data from ads, advertisements and the likes, or watch like YouTube and the likes. Okay, so here are some examples of data visualizations tools. So we have Matplotlib, Seaborn, Bokeh, Tableau, Power BI, and then Data Studio. So these tools would actually help us to present like a graphical representation of these like trends, or get an insight on these data, so a visual, not a textual aspects. And this is going to actually help business people. If they don't want the code inside, they want to actually be able to tell or create a story on their data. Okay, so these tools will actually help us or business developers, business or marketers, to know what is actually happening, trends and the likes. So here are examples of like graphs. Okay, so we have pie chart, we can have histogram. These ones are interactive tools, so we can actually use these tools to create interactivity. So instead of having a still image or a static image, we can actually create some buttons, sliders and the likes to actually help us toggle the insights. Okay, so switch and then know like whatever information we want to get from this like data. Okay, so first the tool we have is we have Seaborn. Okay, so this Seaborn, and then when you visit the link here, you can actually see what and then read the documentation of Seaborn. You also have Bokeh. Okay, Bokeh too has documentation. We have Matplotlib. Okay, and then we have Power BI. Okay, from Microsoft. So these are some visualizations from Power BI, and then we have Tableau. There's also Tableau for some visualization, and then we have Google Data Studio. So Google Data Studio, this is what I'm able to do from my YouTube channel. Okay, so Google Data Studio, you don't need to have any coding background. You just connect your YouTube account, and then it's able to pull some insights out of this for you. So these are interactive, and so it will change. So you need data to be able to make this work. Yeah. So thank you, and then I'll see you in the next lesson, where we'll actually be using Python Jupyter Notebook to do some coding. But as said, you should know that the Python aspects, the first aspect of this program would actually be coding. Then a subsequent videos that are created as when they are available would go to the ones that you don't need to code, so like the Data Studio. Okay, so that said, thank you, and then see you in the next lesson. Thank you. Hello, future developers. So welcome to our lesson on data visualization. So in this session, we'll be learning to plot some values. Okay. So to get started, let's first see what we'll be doing in this session. So we're learning to do this, and then plotting our line, and then our graph will take some form of shapes. Okay. So that said, by default, by default, Anaconda comes pre-installed with Matplotlib. Okay, so we don't need to do any installation. All we have to do is to import. So I'm going to import Matplotlib dot pyplot as what plt. So plt, okay, it's an alias, okay, and then we'll do import numpy. Okay, so numpy is going to help us a lot with this numerical computation. I have a course on numpy. You might want to take that too to understand how numpy works. Like numpy actually helps in processing like um, numerals very fast. Okay, so yeah, so we first importing matplotlib as plt, and then importing numpy as np. So these, okay, np, this alias are going to be, instead of we typing numpy, okay, we can just use np to refer to or reference numpy, plt to reference matplotlib.pyplot. Okay, so the first one is for our graph, and then the second one is for numerical computation. So that said, let's start. Okay, so I'm going to give my x and y value. So first I'll create a variable x, then I'll assign it np. So np numpy array. So numpy array. So an array is going to be a collection. Okay, an array. And then we want to give it some value. So let's use one, two, three, four. Okay. Then we'll create our y. So in our y, we are assigning it a value np dot array, and this array would give it some value. So let's say 10, let's use 20, we can do some 30, then 40. Okay, so we've created our x and y values. Now we would want to plot them. So to plot, we'll simply use the plt. Remember, our reference, our alias is plt. So plt dot plot, then the brackets, we are going to put our coordinates. So that's the x and y variables. Okay, then we can, if we run this, it would work. Okay, but it's best you end it with what, plt dot show. Okay, dot show. Okay, so remember to end your code with plt dot show. Okay, so now let's say we want to actually change the color. So if you look, we have our, this our y axis, so we have the 10 to 40. Okay, and then our x axis has the 1 to 3 to 4. Okay, and then there's the line, there's the graph. So now let's say we want to change this color. So all we have to do is just to copy this, Control C. We want to change the color of our line. We'll place it here, and then we'll give it another property. So this property, we'll use a comma, and I'm going to give it, let's say, in a quotation comments, I'm going to give it RO, or when we say R, okay. So by default, now Matplotlib, the line is blue, okay. So we can change the color. So let's change. So now we've changed it to red. We can also change it to, let's try blue. So B. Okay. So let's go back to red, or let's use green. Okay, so now we want to actually change the type of line. So I'll just have to paste this here, and I'm going to change the line to, let's use comma RO. So RO, sorry, the quotes will put RO. When we run it, we can see we have what, rounded red. So R is for red, and then the circle is that's for the 0 we have here. Sorry, the O we have here. Okay, so we can still do same by using, so R, and then we'll use a dash dash. Okay, run it, you can see we have dash lines. Okay, so these are provided in the documentation of Matplotlib, so it's not like I just came know. Okay, and then we can try doing it with, let's say, some squares. So let's say if you want green, we just put green here, allow it to green. So let's change here to BS, so blue squares. You can see blue squares, and then what else can we do? We can also do, let's paste this here, and then I'm going to use a comma. The codes, I'm going to give it, let's say, I want red hats. Okay, so red hats. When we run it, we should get some triangles. Okay, so shift and then there's 6 on the keyboard. Remember, I struggle to get to this hats. Okay, nothing, was just the 6 on the keyboard. Okay, So now let's see what we can do. We can actually work on, let's create our own graph. So I'm going to create a variable, let's say eval, assign it some value numpy array to bracket, and then the square brackets. Inside the square bracket, let's give some 2 comma 4 comma 6 comma, or let's do 2 comma 6, let's do 15, then let's do, I did 25, let's do 5. Okay, so you can create any variable of your choice, and then I'm going to start plotting. So plt, because I already have it copied, I can just paste it here. So plt dot plot, and then my coordinates is going to be what, the eval. Okay, when I run it, we should get something. Where's the error? Model number has no attributes array. Okay, so okay, so run it so you can see our graph. Okay, now you can see by it generated our x values for us. Okay, so this is the y value. Okay, so we just created the y value, we didn't create the x value. Okay, so let's do another exercise. Next exercise, I'm going to create days, assign it a value. Sorry, let's create some value. Let's say let's use month, and then month would give it np.array. Then I'm going to give some values of let's say 1, 2, 3, 4. Then let's use 5 and 6. Then we'll create that of let's say humidity. So humidity, or let's use humid. Okay, just for humidity. So np.array, and then I'm going to 10, or let's use 20, 30. Sorry, 10, 20, 30, and do some, let's see, 40, and give it some 60, and then 80. Or better still, let's try changing. Let me change here to, let me take the 40 out. Okay, so let's leave it to this value. So plt, I'll change here to month. I'm going to change here to humidity, or humid. Okay, so the other values, so here we can also use color. Okay, and then we just equals, assign it a value, let's say blue. Okay, it should also work. Array takes from 1 to 2 position again, but 5 were given. 1, 2, 3, 4, 5. Okay, so I have to change here to, let me add 70 here. Okay. Okay, so the error is we're supposed to put this in square brackets. Okay, so when I run it, I should get this. Okay, and remember, you can always change the color to whatever color you want. Okay, so thank you guys for watching, and then I'll see you in the next lesson. Okay, thank you. Hello, future developers. So welcome to the continuation of our data visualization course. So in our previous lesson, there was what we were able to do. Okay, just plotting some month and then humidity figures. Okay, so there's a graph. Okay, now we want to work on line and then some properties for using the line. Okay, so that said, let me start with plt. Let me see. Okay, so since we already have this, okay, in our previous lesson, we actually did this. So all I can do or have to do is we have other properties like line style. So line style, let me just type everything. Or better still, let's just start from here. So this is what we did in the previous lesson. So there are other properties that we can do. So here I'm going to type so let's use line style. Line style, we'll assign it and then say dotted see what is happening. Line style. Okay, so I have a spelling. So line style. Yeah. Okay, so you can see we have it dotted. Okay, just going to copy this and then add another argument. So paste this and then from dotted, let's see if we can, let's use dash and then period sign. And let's see what happens. Okay, so you can see the graph is changed. We have the dash and then the dot. Okay, and copy this. And then let's give it another argument or parameter. Let's say color. So color, we can give it a hash code. So hash, I'm going to use FC33FF. Okay, so there's a color. You can change the color. So you might want to go to this color website and then pick some hash values and then change them here. Let me see if we change the values here, if they'll give us a different color. So let me see if I can get any. Okay, so I went online to pick a color code, a hash color code. So I'll run it and see. Okay. Okay, so we can also work on the width. So another parameter, we'll just use line width. Then we'll give it a value. You can give it any value. Let me go with let's say 6. When I run it, you can see it thickens. Okay, the line thickness okay increases. So you can get all this information from Matplotlib. A whole lot of information here. Okay, and let's try this one here. So I'm going to create a variable x, assign it an np.array value, so some values, and then square brackets, and then we can give it, let's say, 2 comma 4 comma 6. Okay, so this, what we are trying to do is we are trying to actually create two graphs, or two plots. Okay, this is two np.array, and then now I'm going to give it, so let's say 10, and then I'll use 3 comma and then 5. Then all we have to do is just plt.show, so plt.show, sorry, plt.plot. So once, let's try the first x. Yeah, I think I getting a lot of errors with my typo. Okay, so let's try plotting plt dot plot x2 x2. Okay, so you can see what we have. So even I didn't bring the plt dot show, but it brought everything. And you can see by default, plt gives us like it gives us different colors for the various lines. So plt dot show. Okay. So we can also add another argument and then change the color. So let's just give it a, let me see, red for this one. Okay, so you can see we've changed the color for this one. Okay. So I think that's it. Thank you for watching, and this is what we can do for some parameters that we've been able to use on our line. Okay, from dotted, um, line star. I think we have diamond. Let me see if we can use the D. Oops. Okay, so you can see the supported ones. Okay, so dash dotted solid. Okay, so let me see solid. It's just the same thing. Let's see. Dash dot is just the same one. Okay, so that said, thank you for watching, and then I'll see you in the next lesson. Thank you. Hello, future developers, and welcome to another tutorial ABCD. So, in our previous lesson, this was what we were able to do. So, with a NP array, so NumPy array, able to plot two graphs. Okay, and then that's a line, and then give it some colors. Okay, so just specifying one color. By default, um, NumPy would generate its own color, but I decided to use the arrow to give one of the lines a color. So if I take this out, you would see what happens. So by default, it comes with its own color. Okay. Okay, so specifying a color would give it the one of the line a color. So now today we'll be working with markers, and then markers are they are symbols that actually represent the peak points of like a graph or a line. Okay, so to do that, let's start by creating our variable. Let's say y. We'll assign it some values. Let me use small letter y. So the small. Okay, let me use u. So let's use y. Okay, y equals. So we assign it a numpy array. Numpy array. Okay, and then I'll give it a value of 10, 210, comma, and then 3, and then 15. Okay, and now I would want to plot, so plt.plot. And then what we want to plot, we want to plot our y value, so y, comma. Okay, and then let's give it a marker, so a marker of O. So when we print it out, you can see we have the marker. Okay, so the peak points, okay, we have them set to the O or a circle. So they have other properties. Okay, so I'm going to copy this. Better still, let's use plt.show. Okay, plt.show. Usually this, you should always end it with plt.show. So I'm going to copy this and then I'll paste this here. And then we'll work with some other properties like, let's say color. So color, I'm going to change the color to, let's use green. So green. Okay, so we've changed the color to green. Okay. So this is actually affecting the line and then the peak points. Okay, that's the marker. So let's copy this and then I'm going to change. Let's see what we can change. I'm going to paste this here and then let's use so color green and then comma. And then I'm going to give it this. So a marker size of 0, so of let's say 10. And print it our marker. Okay, the peak points should enlarge. Remember, we are using a circle. Okay. Okay, so now I'm going to copy this and then let's paste it here. So work with another marker property. So ms. So now let's do ec. So marker edge size. Sorry, marker edge color. So the edge, like the outline. Okay, the outline of the marker. So let's give it a color of let's say red. So r. And print it out. You can see we have some red color just at the outline. Okay, let's copy this and then work with another property. So the next property we are going to use MFC. So that should be marker fill of face color. So just like a fill. Okay, so face color. So face color, let's use B. So B for blue. Let's run it and see. So you can see our fill color or our face color for the marker is blue. And then our outline color is red. So marker edge color red. Okay. Marker face color blue. And then the marker size is 10. Okay. And then the color green, that's for the line. And then our marker is what? The circle. We can decide to change our marker. So we can go to Matplotlib and then we have the marker, okay, properties here. So you can see, so it's best to always use the documentation. You can have all this in your head. So the best thing is just to keep the documentation as you code along. Okay, with time it will get like handy, so you don't need to look on the documentation again and then record. But since you are beginners, okay, should make good use of the documentation. So we have the properties here for the marker. Okay, so V should be a triangle down. So let's change our marker here. So our marker here to V, and then let's see what happens. Okay, so you can see V is gone down. Okay, Let me see any other property here. Let's try which other P for plus, or let's use the asterisk. Okay, let's use the asterisk. So that's the star. So shift and then 8 on the keyboard. So Windows. Okay, so you can see we have the star symbol. Okay, so now let's try this too. So let me just pick the first one, or better, so we can, let's just use this one. Okay, so Control C, I'm going to paste this here. And then let's do away with this. Okay, so now what we would want to do is to, let's say, P, sorry, in the quotes, so P, okay, and then we have G. Okay, so let's print out and then I'll explain what we are doing. Okay, so you can see what is happening. So the P, okay, is for the marker, the dash, and then the period sign is for the line, okay, and then the G is for the color, so which is green. Okay, so when I decide to change here to, let's say, let's use D. Okay, so diamond, you can see the marker is changed to a diamond sign. Okay, and then let me see the properties for the line. So let's say line. Okay, so we can also use W3 schools to also help us get something. So let's see. So we have the marker, we have asterisk for star, we have what? Capital P for plus. So let's, we've done P. I think we did small p. Okay, let's scroll down and look for line, some line properties. Okay, so the line properties. Okay, so we have colon. So let's try colon for our line. So colon, let me just take this out and then do colon. Okay, and then let's print out. So you can see we have it changed. Okay, so that said, I think that should be it for today. And then thank you for watching, and then I'll see you in the next tutorial. Thank you. Hello, future developers. So welcome to the continuation of our data visualization course. Okay, so in our previous lesson, there's what we were able to do. Okay, do some plotting with some marker. Okay, changing the style of our marker, and then the line, and then the color of our line. Now this time we want to actually label our axis. Okay, axis. Okay, so we have the legend label and then the title models in Matplotlib. So let's get started by creating some values. Okay, so my first variable is x, and then I'll give it an np array. I'm going to give it a value of, let's use 0 comma 2 comma, so I'm going to pause and then just type them in. Okay, so I'm done typing. So I created a variable x, okay, and then I assigned it some values. Okay, that's an empty array, and there's a value. So another y, and then there's a value for the y, and another x. Okay, so we are plotting two lines in our graph. Okay, so these are the values. Okay, so now let's try and then plot it. So we're going to do plt.plot. So plt.plot. In the parentheses, we'll do plot. So we'll do x comma y. Sorry, x. Yeah, x comma y, and then comma x2 comma y2. Okay, so let's run it and see what comes up. Okay, so we have this now. So now all I have to do is just to copy this, and then let's try doing some things here. So I'm going to paste this here, then let's give it a marker. Okay, so comma marker. Remember, don't forget, sometimes I do type maker instead of marker. Okay, so remember you have the r there, then we'll assign it. So our marker, let's give it a capital P, so a plus. Okay, and then I'll do plt.show, plt.show. Okay, so I think we didn't do plt.show for this. Yes, I would always advise you to add plt.show. Okay, even though it keeps like showing, but your last code, okay, should end with plt.show. Okay, so you can see with the plus, the marker capital P, we have the plus at the peak points. Okay, and by default, NumPy gives us some default colors. Okay, so you can decide to change the colors as always. So now let's try with the legend. Okay, or let's try with the label first. So the label is going to be, once our x and y axis to have a label. So our x axis will be labeled and then our y axis will be labeled. So all we can do is let me just come somewhere here, and then I'm going to, okay, so it has a label. So let's do plt dot x label. So x label model. Okay, so it's not this x. Okay, it's just the has a label property. Matplotlib has a label property or model. So x label. So x label, I'm going to give it a value of let's say. So what do we want our x to be? So let's use days. So days. Okay, and then my plt dot y label, I'm going to give it let's say temperature. So temperature. Okay, so now let's run it and see what happens. Okay, so you can see we have the temperature for our y label and then the days for our x label. Okay, so now let's work on our, should we do legend first? Let's do title. Okay, so we would want to title. I remember in junior high, these things were being marked. Okay, if you have your title, it gives you a score, the likes. So plt dot, let's use title. So title. So title would be, so my title is going to be let's use weather. Don't worry, we can use any name. So I'm just going weather. So what happens here? Name plt is not defined. Okay, so plt dot title. Okay, so I think the PLT, I need to use small letter. Okay. Okay, so you can see now we have the weather. Okay, so I have a score for this, score for temperature, another score for this. Okay, so we are, yeah, doing well. Now, let's work with the legend. So the legend is going to be something like a key. Okay, so PLT dot, let's do legend. So legend in the brackets would put labels, and then the labels, let's say, so the month, I'm going to use, let's say, September, and then I would use, so I should be in quotes, so September in quotes. Then I'll use, let's say, June, July. Okay, so currently in Ghana here, our raining pattern or weather conditions is being changed because it should rain in June, July, but here we are in September and then it's raining like, um, it's just raining anytime it likes. Maybe this global warming is affecting us now. Okay, it's a global issue. So yeah, so September and then let's say, so I'm hoping December to have another raining, like rain. Okay, so December, and then outside of the parentheses, that's this one. I'll put a comma, and then we have location. So the location where we would want our legend to be, I'm going to give it a value of 9, and then let's see what happens. So when I right click, you can see we have it centered here because the value is 9 here. Okay, so you have it centered, and then this our legend, September, December. There's the rain pattern or graph. Okay, so if you look at the documentation here in Matplotlib, you'll notice like you can use, so there's the location code. Okay, so if you want the string, you can use type strings or you can use um, numbers, numerals to actually get the location. So let's try using center or upper left. So to do that, okay, we want a string, so I'll put it in quotes and let's use upper left. Okay, so you can see it's moved. Okay, so you can decide to use what strings or numerals or numbers to help you with the location or positioning of your legend. Okay, so our legend is serving as a key for to help people identify what the graph or a line is referencing or trying to talk about. Okay, so that said, thank you for watching, and then see you in the next lesson. Thank you. Hello, future developers. So welcome to the continuation of our data visualization course. So now, in our previous lesson, what we learned to do was to do that of the legend, okay, the title, and then the labeling. Okay. So now this time around, we want to use grade. So grade, in JHS, I learned about grade like graph. You see those boxes, tiny boxes that would help us to actually focus or do the plotting. Okay. So grade. Okay. So from those from the web development background, like CSS grade and the likes. Okay. There's the kind of grade for Python or Matplotlib. So that said, I'm just going to copy this from our previous code. Okay, then I'm going to paste it here. Okay. So now what we are left with is just to do some plotting. So I'm going to start with plt dot plots. And then what I want to plot is I want to plot my x and y coordinates, so x comma y, and then I'll set my this particular coordinates, okay, to blue, so b, sorry, let's do b, so blue, and then we'll give it, so the peak will give it an asterisk, and then we'll give the line colon. Okay, so let's plot it out and see what happens. So plt dot show. Okay, so that's for the first one. Okay, so you can see we have the dot dot or dash, and then we have the asterisk or the star for our peak point. So now would want to work with plt dot plots brackets, and then we want our x2 comma y2. Okay, these coordinates, and then comma would also want to give it, so inside the codes we'll give it some properties that want this to be yellow, and then capital P for the peak points. Okay, and then let's use dash dash. Okay, so let's run it and see. Okay, so you can see yellow. It doesn't look more like yellow, but yeah, the yellow family. And then our plus, okay, for our peak points. And then our line is dashed. Okay, so let's see what else to do. So now we would want to actually work PLT. So let's work with the label. So PLT dot X label. My X label, I'm going to call it days. And PLT dot Y label. And I'm going to call it, let's say, temperature. And now I'm going to give. So it's basically the same thing as we have here. So all I have to, let me just copy this. I'll just change and then we'll add some code to it. So let's paste this here, Control V. And I think we need the title. So plt.title. Okay, we already have temperature. So plt.title. Okay. So our legend. Okay. In the previous lesson we learned our legend. So here we want our legend to be at let's say lower right. Okay, we can actually use a string or you can use the number. That's numerals as I showed you in the other lesson, previous lesson. Okay, so instead you can use strings or numbers. Okay, so let's run it. Okay, so we have our legend, okay, our title, and then our labels. So our legend. So now we would want to add for some grade. So to do that, we'll do plt.grade to brackets. It's just like CSS flex. Okay, so display flex, display grade. Here we have plt.grade, and then the parentheses I'm going to give it a color. Okay, so color equals we'll assign it, so equals let's use blue, so B for blue, and then I'm going to give it a line style um, of, let's use dash dash comma, and then we'll a line width, so LW line width of let's use 30. Okay, so I think this yeah, this is Let's run it and see. Oops. Okay, so you can see that how to change our thickness to, let's see, 0.30. Okay, so when I run it, okay, so you can see now we have our grid. Okay, so you can change the thickness to, let's see, I can change to 10, and let's see what happens. Run it. Yes, okay. So there's our grid to help us to actually get some exact positioning of our location of our coordinates. And then we use lower right, which is why we have our legend at the lower right. Okay, so yeah, so that should be it for our grid. Let me see which other property. Let's just try change this grid color to green, and let's see what happens. Okay, so we have the green grid. Okay, so that should be it for our grid, and then thank you for watching, and then I'll see you in our next lesson. Thank you. Hello, future developers. So welcome to the continuation of our data visualization course. So in this session, we'll be learning about bar charts. But in our previous lesson, we learned to actually do this with grid. So now let's work with bar charts. Okay. So we learned to display some grid in our charts. Now we would want to work with bars. Okay. So remember we have histogram, bar, pie chart, and the likes. But this session is focused on bar charts. So I'm going to create a variable and then assign it an np array. And then let me give it some, let's say, mango. I'm going to pause it and just type it. Okay, so I've created my numpy array. Okay, so mango, cashew, coconut, and then guava. Then in my x, so my y, I'm going to create numpy array, and I'm going to assign it a value, some values. That's the numpy array. The value, let's say 200, comma 300, comma I can do 100. Let's do 30. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, and then let's do here, let's say 70. Okay, so now all I have to do is to just plot. So plt dot plot plot, and then we want to plot what's our x and y, x comma y. Okay, remember to end it with what plt dot show, and then let's run it. We have an error. Let me see where the error is. X and y myself. Okay, so this is for this is 5. Okay, so let me just take one out. So the shapes 3, 5. This one has what? 1, 2, 3. This one has 5. 1, 2, 3, 4. Okay. Okay, so now to display our bar, we need to actually change it to what? Bar, and run it. Okay, so you can see we have the bar charts for, so mango has 200, or cashew has 300, and then the coconut has 100. Okay, so this is basically how to display like a bar chart. Okay, so you can also change the color as usual. Just give comma, and then we'll just give it some color to green. So set our color to any color of your choice. Okay, so I'm going to use G for green. Then we have it changed. Okay, so we can actually make our bar chart, instead of vertical, we can make it appear like horizontal. So to do that, we just have to, let me copy this, Control C, and I'll paste it here. Then I'm going to change, just add H here. Okay, run it, you can see it's now horizontal. And then we can work on the width. So width, comma, so width equals, let's try 0, 0 point, let's use 0 0.5. run it. Okay, so this error occurs because of the age. If I take the age out, okay, I should get it. Okay, so you can see the thickness has changed. Okay. So when you have the age, you don't have to actually they don't match. So what you have to do is to actually change here towards height. Okay, so height. Then when we run it, we should have it. Okay, so you can see um, yeah. So when you have the horizontal, that's it being horizontal, you need a height to work on the thickness. But if here is width, you would notice that we got an error when we change it to width. Okay, so the width will work when we don't have the h, the horizontal, as you see here. If I change to width, it should work properly. Okay, if I bring the h, it should give us an error. And then to fix it, we need to change here to height. Okay, so yeah, so debugging once more. Okay, so now let's try another exercise. So I'm going to create a value. Let's create a variable called girls. Then we'll assign it some numbers. So let's say 20, 30. Let's use let's use. Okay, so I'll pause it and then type it in so that it doesn't delay us. Okay, so we actually want to achieve something like this. Okay, so I've populated this. Okay, so we have girls with these values and then boys with these values. Now let's try grouping them. So we'll create another this thing variable called group. There's going to be an np.arange. Now the arange property is just going to help us get numbers from what 0 to 4, not 5. So start counting from 0 to 4. Okay, so if you actually want 5, you would have to put 6 here. Okay, but we want 4, so I'm going to put 5 here. Okay, you might want to check my numpy course, okay, to understand numpy. Okay, so now let's try plotting. So let's see. So plt dot bar, and we want to group. So our group variable here. Okay, then we're going to do girls. So group girls, and then let's give it a width of point. Let's use point 20. Then we'll give it a color. So a color of let's use yellow. Okay. Then I can copy this again. I'm going to paste this. Now I'll change here to boys. Then still the same, and then we'll change here to let's use blue. Okay, and then comma would button equals um, girls. Okay, so the button equals girls is actually going to place the girls below and then the men above, as you saw in the as you see here. Okay, so bottom, okay, will push one of them up or one of them below. Okay, so let's change here to let's add this plt. So we want to plot plt dot x label. X label would be let's use smiles. Okay, so we're trying to create a bar chart to see the number of people, like males and females, who smiles more. I'm going to copy this and paste it here. So I'll paste it here and change it to y label. So here's going to be the groups. And then I'll paste this. I'm going to change plt dot let's use title. So the title, let's use Let's use smiles by gender. So smile by gender. And let's use plt.white text. Okay, so we are actually going to create our own text. So you see here to create our own text. So here I'm going to do. So let's do here x text. Okay, so x text, and then our s text. Let's give groups. A group. Okay, so the group here. And we are going to give it a name, some names. So let's use G1, G, or pause it and then just fill it in. Okay, so I've created a group. Okay, so our s text. Remember, I added another value here, which is 30. So now I'm going to have to do just I can actually let's just do plt dot white text. So white text let's do an np dot range. So np dot a range, sorry, a range. So the a range would start from 0, would want to start counting from 0, and then we want it to end at 80, or let's use 90. Okay. So it's going to count from 0 and then will end at 89. It wouldn't print 90. Okay. And we want it to do that by a step of 10. Okay, so 10, 20, 30, 40, 50, 60, 70. Likes. Okay. So the start and then the end and then the steps. Okay. Our PLT does legend labels. Our labels equals let's create a list. So our list is going to be let's use boys, comma, and then girls. Okay, so now we have to PLT dot show, and then we run it. Let's see what happens. Okay, so you can see we have our text, white text, we have the smalls, and here we have so the legend boys. So we have let's look here. So the number of people smiling here are girls in this group 3 compared to that of boys. Okay, so that's how to actually work with grouping. You might want to take your time and then go through each line of code to actually understand it. If you don't understand, I think here would be the issue. Uh, this is the another concept that you've introduced to, so you might want to practice it. So you can change here to boys and then see what happens, or you can copy this, paste it here, and then change um, to boys. Okay. Okay, so that's it. Thank you guys for watching, and then I'll see you in the next tutorial. Thank you. Hello, future developers. So welcome to the continuation of our data visualization program. So in our previous lesson, we actually learned to do some grouping, like as you see here. Okay. So today we'll be learning to do some histogram. That's a frequency distribution table, like yeah, like frequency, how frequency occurs. So that said, I'm going to create a variable x, then I'll create a numpy, so np the random. So random is going to create generate some random numbers. Okay. When I say random, these are unpredictable numbers. Okay, so and then we use the normal just so we get like normalize everything. So random dot normal. You might want to read them more when you go to the B3 schools or the Matplotlib library. Okay, or page. So no, normal. So I'm going to create some values. So 50, comma 5, comma and then 150. Okay, so this is actually going to create an array of 150. That's 150 arrays, and then it's going to be centered around 50, and then our standard deviation is going to be 5. Okay, so there's something that's for most students can actually understand this, but if you want more, you can go to W3 schools or Matplotlib page to understand standard deviation. Okay, So if we want to print, so I'll just use X and I'll run it. You can see we have some random numbers being generated. Okay, so we want 150 of them. So that's an array. So now what we'll do is we are just going to plot, so plt dot hist, so histogram hist, and then X. So let's run it, and then you can see we have this. Okay, I wasn't expecting this. Let me see. Okay, so plt.hist, let's put a comma here, and then let's give it another color, or let's change the color. Let's give it, let's say, green. Okay, let me do plt.show. Then let's run this. Okay, so we can have this. So somewhere here, okay, we have the highest frequency somewhere here. So even if I run this, it's going to change. Our graph is going to change. Our histogram is going to change. You can see because of the random. Okay. So this about histogram, but I think we have the density. So density, let's set it to true. Let's see what happens. Okay, let's check the documentation for density. So here's the actual documentation for density. Okay. So there's the formula for density, how it works. Okay. Yeah, there's not much to say here. Okay. So that's density in Matplotlib. Yeah, so you can decide to change the figures here and play with the colors, and I think that should be it for density. There are more functions as you see here. Okay, more functions for the density. Sorry for histogram as you see here. Okay, so that's it then. Thank you, and then I'll see you in the next lesson. Thank you. Hello, feature developers. Welcome to the continuation of our data visualization course. So today we'll be doing pie charts. In our previous lesson, we worked on histogram. Okay, now we'll be doing pie charts. Okay, so I'm going to create a variable x, then assign it on np.array. I'm going to give some values. So let's just use 10, 20, 30, then 40. Then let's just plt.py, and then you can put our x there. Basically, so this is just a simple. So plt.show. This is just a basic or simple way. Okay, so we have our pi. Okay, so now we'd want to actually add some labels. Okay, to add some labels because let's try this. Let me just copy this, Control C, and then I'm going to paste this here. Okay. So I'm going to create another this thing called tags. Okay, so this tag is going to help us with our labeling. Okay, so tags or something to represent what is section. Okay, or sector. Yeah, sector. Okay. Yes. So let's see. So my tags are going to be, let's use square brackets, and then so it's a list. And then I'm going to create some programming language. So C plus plus. Okay. C plus plus. I don't know if there's a language called C equal to. And then C. I'll pause it and then type it in. Okay, so I've populated my list. Okay, so I have C++, Python, Carbon, and then Dart. I think Carbon is one of Google's new projects. I think it's going to replace C or C++. I don't remember. But okay, so what I would have to do is basically, since we have the tags, I'm going to go with a comma, then I'll use labels. So labels, course, then we use what tags. Okay. So whichever variable you use there, remember to use it here. When I run it, you can see we have oops what happened? ATSG. Yeah, sorry, it's a variable, alright, not a string. Okay. You can see we have Python. Now I feel that is taking a larger percentage. I'm programming Python, so I'm going to change it. So where's Python? Let's do here like 70. Yeah, so Python should take the larger value. Okay. So next, let's just copy this code again. Then I'm going to have to paste it here. And let's see. So we actually want to separate or like detach some of the sectors. Okay. So to do that, we have let's create a variable called my explode or my ESP. Okay. Then I'm going to give it some list, a list of values. So the list of values, so 0.2. Okay, these values tells us like the distance from the center. Okay, how we should split. So we'll set the rest to 0. How for 1, 2, 3, 4 values? 0, comma 0. 1, 2, 3, 4. Okay, so plt.py x labels. And then I can do, or better so let's see. Let's try this first. Let's cut this. Let's let me take this out. I'm going to do here start angle. So this helps us to actually rotate. So start angle. Okay, so start angle equals, let's use 180. So let's look at what we have here. Okay, Python is a C++ dot. So look at the location and let's see how this is going to work. Okay, if you run this, what happened? Okay, I have to bring the tags. Okay, so tags. To bring the labels. So labels equals tags. Okay. So you can see now we've changed rotated it 270 degree. If I change it to 90, it should rotate. Positions are going to change. So let's see where carbon is going to go. So carbon is now at this direction and Python is here. Okay, so let's work on this one too. So my explode, remember we created this called my explode. Okay, so these values are going to tell us the distance. So if here these ones are set to 0, so it's not going to split. So let's try that out. So I have what my exp. Let's put a comma. My exp, or better still, let's do sorry explode. So the function explode equals, okay, so explode equals my exp, which is this. And let's, so you can see this one C++, which is the first one, is what detached from the center with the value of 0.2. If I do here 0.1 or zero point 0.2, let's do 0.1. Okay, and then let's run everything. You can see we have another detached. Let's try another 0.1. Okay, you can see what is happening. Okay, so now let's do this with shadow. Set our shadow to true, just so we get a 3D like effect. So true. Okay, and we run it. Shadow. Sorry, comma. Okay, so you can see we have some shadow behind our text to make it look like a 3D. Okay. So let's try adding a label like a legend. Okay, so to do that, I'm going to have to, let's take this out. Okay, so plt.py x labels equals to tags. Okay, so we'll create a legend. So plt.legend. and set a title. So our title equals, let's use programming languages. Programming languages. And then the location. So location equals, okay, you can use numerals. So let's use 9. Let's see where 9 is going to position it. So 9 is positioned here. Let's try 5. Okay, 5 is positioned here. But you can also do with text or strings. So strings, I'm going to do upper left. Okay, so we have it here. Okay, that's, we have it already labeled here, and then we also have this legend abstract, and you can see behind it we have Python behind the legend, which isn't good, or which isn't what we want. Okay, so we need to work on this. So let's get that done. Okay, so to do that, let's do this. I'm going to take, let me see what to take out. So we need to work. So we take this out. So the labels from here, and then our legend, okay, has the labels. So we're going to put the legend at our label side. Okay, so labels equals tags. Okay, so now we have the tags being removed from the circumference, and then we actually displaying everything in our legend. Okay, so now let's work with some percentages. Okay, so let me take this out because we're not going to explode anything. And then we have this, right? So in our plt.legend, we can actually work with, actually take out, let's take this out. Then I'm going to change this to, let's use percentage 1.0, and then I'll do um, ff, sorry, f, and then percentage. Sorry, I need to put them in quotes. Okay, so when we run this, let's see what happens. End of line. Wow. Okay, string literals. Okay, so let's take this out. Another one. Mm, okay, sorry. We actually need to use the auto percentage PCT. Okay, yeah. Auto PCT. Let me see the error. Auto PCT. Let me try taking the title out, and then let's see what happens. Oops, Control Z. Title. Okay, so when I run this, still auto PCT. Okay, so it shouldn't be in the legend because that's not what we actually want. So I have to take this out, Control X, and then take the legend out. And I'm going to put a comma here. So I put a comma here, and then let's paste this here. Now let's run it, and let's hope everything works. Okay, so you can see we have Python taking 47%. Okay, so a lot of people are taking the Python course, C++, 27% for that, 20% for Carbon. Okay, so there's how to actually work with pie charts and some codes for pie charts. Okay, so that's it. Thank you for watching. See you in the next lesson. Thank you. Hello, future developers. So welcome to the continuation of our data visualization project. So in our previous lesson, we actually learned to do some plotting. Okay, using in pie charts. Okay, so as you see here, some few lines of code. We also were able to achieve. Now we would want to actually do something with scatter plot. So to get started, I'm just going to create an X variable, then assign it an NP, so numpy array, so np.array. Then I'm going to give it some values, let's say 3, 6, 10, and then 35. Oops, not comma. Okay, so I'll just copy this. Okay, so scatter plots, let me paste this. scatter plots just helps us to distribute some points, okay, on a graph, and then it actually shows the relationship between these points. Okay, so np.array, and then let's change here to, let's change the value. So I'll do here 30. We can do here, let's say let's do here 50. You can use any value of your choice. I'm going to do here, let's use 77. Then here I will do, let's say 20. Okay, so now let's try plotting. So very simple. So plt.scatter. Then what do you want to scatter, or what do you want to plot? Which points? So x comma y. Okay, so remember to actually use plt.show to make everything work. Like, yeah. So run it. You can see we have some points, okay, scattered, okay, in our graph. Okay. So now what we'll do is let's try. I'm just going to copy this. Okay, we'll use it in on Excel. Paste here, and then let's try creating two of these. So let me cut this, Ctrl X, and then paste it here. Then I'm going to copy all of these. Okay, I'm going to paste it here, and then we'll just change the value. So let's change the value. So 2, do here 4, do here 9. I'm going to do here 7. So 7. And then our y axis is going to have, let's say 40, 30, 90, and then let's use let's say 99. Okay, so let's try running it. Okay, so you can see we have the colors being different. Okay, so this would be the blue one. Let's first confirm. So 3, 30, so 3, 3, 30. Okay, yeah, you can see it here. Then let's see that of the orange. So 240. So 2 should be somewhere here. Okay, so you can see 240. Okay, so yeah, let's move to our next lesson. Okay, so our next experiment, let's try just pasting this here. First, let me put the plt.show so that we don't forget. Okay, and then let's try working on the size of our points. Okay, so the points we want to work on the size. So I'll create a variable size, assign it an np, that's an array, numpy array. Then let's use some values. Let's say 100, comma, let's use 300, 200. Let's try 500, and then let's try 700. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. So all we can do is just to use let me create a variable s. Sorry, let's use s for the size, and then we'll just assign it our variable here. Okay, so s for size, and assign it the values, okay, in our size code. Okay, so if you run it, we should see that the size of our points have changed, okay, or are changed. Okay, let's try adding some colors. So to add colors, all we'll do is just to let me use colors. I'll create a variable called colors, or we can use hue. So hue. Okay, so any variable name, and then np.array. I'll keep typing array. From Jamaica, array. Okay, so array, np.array, and then let's give it some colors. So I'm going to use yellow. Let's use cyan. Is it cyan or cayenne? Then let's use green. So 1, 2, 3. Okay. Then the last one would use let's use red. You can use any color of your choice. When we run it, you could see what's issue. Okay. So let me comma, and then I'll put color. So C equals to hue. Okay, so C equals to hue. If I run it, you can see we have our colors changed. Okay. Okay, so we can also try to make this a little bit transparent or faint, like try to add the alpha method or property or object. So to do that, we just have to put comma and then we use alpha, and let's use 0.5. We run it, you can see it's been fainted. Okay, so we've decreased the saturation. Okay. So that should be it for scatter plots. And then I'll see you in the next lesson. Thank you. Hello, future developers. Welcome to the continuation of our data visualization program. So today we'll be learning about box plots. Okay, so box plots help us to get some quartiles for our graph, okay, or values like representations. So first, we would want to understand certain things like np dot random. Okay, so it gives us some random numbers. These random numbers are not predictable. So we have the seed function. Okay, then I'll put a value here 0. I'm going to put a value here 0. And then np dot random dot rand with an n. Okay. So when I run it, let's see what happens here. So you can see we have this value. Okay, so if you run this program, you should have the same value. Let's copy it and then run it again, or let's just run it again and see what happens. Nothing changes, it's still the same value. Okay, so if this has no value, let me see, let's run it and see. You can see it's changing. If I run it again, it should change. Okay, so if you input a seed, any number here, um, anyone having that same code would also receive the same number or value. Okay, so let's try something here. So let's say we want to create a one-dimensional array. So let me see, let me put any value here. So 2, and I'm going to put let's say 1. Okay, so when I run this, okay, I should get this value. Okay, so just one value for our row. Okay, so let's try putting, then put a comma here, and then I'll put let's say 2. When I run it, what should we get? So we have what, 1. So this is our row. Okay, and then this is our column. Okay, so then put another value here. Let's say I want um let's put 10 here. And I run it, let's see what we have. So you can see we have 2 columns. Okay, so this is the first column, sorry, this is the first row. So our first row, and then our second row. Okay, and then the 10 here, so the first one is our row, the second one is our column, then the third one is our, like, the numbers we want our values to be, so the differentiations between the or the values that we want. Okay, okay, so let's try something. Let me change here to 0. Okay, then I'm going to do here, let's say 2 comma 3. Okay, so we have what, one row, another row, okay, and then 3 columns. So the first column, second column, and then the third column. Okay, so 2 rows, which is first one, and then second one, and then 3 columns. Okay, so the first one represents the row, the second one represents the column. If I take this one out, we should have just 2 rows. Sorry. So one row is for 2 items or 2 values. Okay, now let's try. So comma, let's do here 4, then let's do here, let's see, 6, and then let's run it and see. Okay, so we should have 2 rows, 4 columns, and then values within this 6. Okay, okay, so I'm hoping you guys understand this. Okay, so if you want to have so if you type in the same this, you should have the same values. because I put a value here. If the value isn't here, okay, if I don't give it a seed, what will happen is it will just keep changing. Okay, it will just keep having different values. Okay, so if I put a value here, no matter the number of times I change it, I also get that same value. Okay, I should have that same value. Okay, so let's move to, so I'm going to type np, let's try plotting something, np.random dot seed, and then let's put 10 here, then put 10. Then I'll do, let's say I want, let's use info, so info equals np dot random dot normal, then the normal I'll put 100 comma 20 comma 200. Then let me put, so let's create a figure. Okay, so a fig for the size, once you create a fig for the size of our image, so plt dot figure, and then the figure size. Okay, what's the size of our image? So figure size, we want our figure size, sorry, brackets, this would be a bracket, our fixed size to be, let's say 15, 15 by, let me use 10. Okay, I need to close the parenthesis. Okay, and then let me do plt dot box plots, so box plots. Then as usual, we'll pass in our info. Then outside it, plt dot show dot show. Okay, so when I run this, let's see what we have. So we have this. Okay, so my fixed size is large. Let me change it to, let me use 8 by 8. Okay, so this is quite okay. You can see we have some outliers. Okay, like quartiles and the likes. Okay, so this line of code is going to give us, for this going to be our um, row, and then this is going to be our column, and then this is the values that we would want our numbers to be within, or to be with. Okay, so if we run this, no matter the number of times we run this, we'll get the same thing. Okay, because of the seed we have here. Now if I change here to empty and then I run this, anytime I run it, you can see now we don't have outliers. Our figure is going to change. Let's run it another time. So you can see it's changed again. Okay. Okay, so now let's try creating some um, multiples of this in one graph. Okay, so np dot random dot seed, and I'm going to put 10 here. Okay, so this is going to ensure that we all have the same values no matter what. The number of times you run it will get the same thing. So let's create info. I'm creating an, so let me use info one. Okay. Then I'll do np dot random. Then let's put some values. So let me say I want 10 comma, I want 20 comma, and then I want let's say 70. Okay, so I'm going to pause this and then duplicate this 3 times. Okay. Okay, so I've populated this. All I have to do is change this. Let me say info 2, info 3. So these variables, info 4. Okay, and I gave them some. Oh, I should have done dot normal, and pause the. Okay, so the normal is just going to help us with us getting like a normal distribution of data. Okay, so this what I did. I just changed the values and then add the normal. Okay, created a variable with these names. So now what we'll do is let me create, let me store them in something called, let's say, all. No, all is the keyword. So data equals, and then let me create a set. Sorry, a list. Okay, and then we want to store all our info inside. Okay, so we are storing this. okay, our variables inside this data, which will be called later in the code for us to be able to draw the box plots. Okay, so all I have to do is to come here, pick this. I'm going to paste it here. Okay, then next what we'll do is to, okay, so now we'd want to set the width and height of our plot, just so we have the different the random values, okay, inside our like different box plots. So to do that, let's create ours, or let's see, ours would give it some so fake dots, and then we use the add function. So add underscore ours, so add underscore ours. Okay, okay, so this add, okay, so this is a function in Python like NumPy. Okay, so this as this isn't referring to this. This can be any variable name. Okay, so this as this is a function in NumPy. So the first argument, I'm going to say 0.75. You can use any value. Let's see, you can use 0. I'm using, so I'll use 1, comma 1, then comma 1. Okay, so I have 0 for our x min, and then 0 for our y min. And then here is going to be the height, and then this one is going to be the width of our box plots. Okay, then let's create a variable to help us draw. So I'm going to use let me just use draw as this dot box plots. Okay, so data, remember which one is data. Okay, we stored it into data, and then all we have to do is to plt.show, and then let's see what happens. Okay, so you can see we've generated a box plot, okay, showing the medial outliers. We have our percent, is it percent quartiles, median, and the, like, yeah, these things for standard deviation and the likes. Okay, so this box plots, I think my size here is too big. Okay, so you might want to go over this video again to actually understand what these values stand for, okay, or parameters stand for. Okay, so thank you, and then I'll see you in the next lesson.